This video is going to be a little bit shorter than the other ones. We're just going to be talking about the cerebellum and the diencephalon. Cerebellum, starting off with the cerebellum. Cerebellum is that guy on the back caudal ventral portion of your brain. If we're going to use other anatomical nomenclature, it is the posterior inferior portion of your brain. And you will see that it has these nice, wonderful little folds. Here's the anterior, posterior. This is a superior view. This is an inferior view. You'll notice that it has not two lobes, just like or two hemispheres, just like your brain, your cerebrum does. But this is connected by a vermis. If we were to take a sagittal cross section of that brain, of that cerebellum, you would notice some interesting things. It kind of looks like a tree. And that little bit of visual knowledge didn't get past the first anatomists. In fact, they called it the arbor vitae. Arbor vitae in Latin means the tree of life. So this white matter, those axons, is called the tree of life. And take a stab in the dark, what all these are going to be called? A lot of you might be saying leaves, which is absolutely correct. They called it folia, or foliage, which means leaves. Now, something to remember is that the cerebellum has a lot of the coordination of your skeletal muscle contractions to help you maintain your tone, your posture, the smoothness of how it works, getting all your muscles to help move appropriately so you can function just right. And that is about all we're going to talk about for the cerebellum. Also, it has a lot to do with your muscle memory. One thing that was kind of neat about the cerebellum, just a quick FYI, we had a researcher that actually put an electrode into the cerebellum to count the activity of the brain waves, aka giant waves of electrical activity in the cerebellum. And as the ape was going out and grabbing things to eat, like a grape or something, that cerebellum you could hear it reacting as it was reaching out its arm. But if it made a mistake, you would hear a huge amount of it going off. It was learning what mistake it had made, and it was not going to make that mistake again. So the diencephalon, let's go ahead and pull into that diencephalon. Diencephalon's right there, smack dab underneath your cerebrum. It's above your cerebellum and brainstem, and it's composed of three different things. Your thalamus, which is this middle piece, this guy right here, followed by a hypothalamus, which is this region right there, and an epithalamus, which doesn't look very above that diencephalon, but we're going to let it roll. Hypo means below, epi means above. Hopefully that helps you remember the regions. So again, it's smack dab in the middle. Let's go ahead and pull apart these things. The thalamus has tons of different locations and areas and all that stuff that tell and regulate certain things and helps it know which signals go where. If I were to summarize the thalamus, I would say it is the relay station for all sensory impulses, as well as some of your motor signals. It distributes it. If you're going back to the 1930s, 1940s, when they still had the switchboard operators, where they'd say, okay, where would you like to go? And say, oh yes, Madame Lupin. And they go, okay, and they move your cord up to Madame Lupin so you can talk with her. This is the same type of thing going on with the thalamus. Certain signals are being sent up from different parts of the body, different senses, and those senses are being distributed to the varying bits and pieces of your brain that need to have that signal so it knows when and how to respond. The hypothalamus, this is your major regulator of homeostasis. It does hormone production. It does the thermostat. Are you hot? It's going to try cooling you down. You're going to sweat. Are you cold? It's going to try and make things go warm. It's that sense for that. It's that thermostat. It checks for that. Are you hungry? It's going to check. Wake sleep cycle, that's your baby. Control of the autonomic nervous system. You freaking out? Epinephrine, better pump it out. Now, because it has all these things, all these thermometers hanging out and checking things, it has to be close to blood, which means this is one of the very few places in your brain, the only place I'm feeling safe to say, that has no blood-brain barrier, because it has to have all of that interaction. It has to be able to sense the outside world without any type of delay, and sensing from the blood is a great way to do that. Plus, it also has a lot to do with releasing hormones. And if it has to release those hormones into the cerebral spinal fluid, then it has to cross that blood-brain barrier, which is very selective. We're going to have some issues. It's just easier just to release that hormones into the blood itself. Now, the epithalamus, there's two locations that I really care about for now. You got your pineal gland and your habenular nuclei. Now, the epithalamus has the pineal gland. Pineal gland secretes melatonin. So when you go outside, when it gets real dark, you turn off the lights, you put up your dark curtains. Those of you that have worked nights, you're trying to stimulate the release of melatonin. If it gets dark enough, melatonin is released and it induces sleep. Those of you that have been to a complete solar eclipse where you don't have to have the glasses to actually see the moon cross in front, you can actually see it get dark around you. Super jealous first. I'd love to go see that. Secondly, when you do, if you go and do it and go to see it, I want you to listen as well, because you'll hear those birds chirping away until that darkness comes, and you'll hear all those birds go quiet. And a couple of minutes later, when that moon moves out of the way of that sun, you're going to hear all those birds go, what just happened, and start chirping up again. It's a fun, neat little event. It's just that melatonin telling them, okay, it's time to sleep. And that happens with you too. Now, those of you that have that if you ever smelled something very pleasant, it brought back your great grandmama's wonderful cookies and her wonderfulness and how great she was, or how great, or you smell shoe polish and you remember that time that you used to polish shoes for a living, or something like that. It just sparks those memories. You can thank the habenular nuclei. And those of you that have unpleasant smells and have associated bad memories associated with those unpleasant smells, you can thank the habenular nuclei as well. It helps with that relay. This just mentions again that portion of that diencephalon lacks that blood-brain barrier, so you can have that chemical signaling. It does include the portion of the hypothalamus, includes part of the pineal gland, and then there's that pituitary gland that's hanging off of that hypothalamus. Now, that is the end of this video. We're going to go ahead and go into the cerebellum, my bad. We already talked about that. I will talk to you all shortly.